Hi guys, welcome back to the part 2 video of multiple docking. In this video, I'll teach you how to do actual multiple docking using PyRx. First, you have to download the PyRx. Let's go to PyRx download. So you can see downloads by the PyRx Python prescription. So let's open that. It is taking more time. Is coming. You can, if you have money, you can choose with the academic version or by paying $1,000. Since I don't know, I'm broke, I'll just go with the free software. I'll choose this and then you have to download. Yeah, it will download the setup file. You have to install the setup. Since I have already installed everything, you have to, I don't want have to go through the installation process. So just you know how to install setup. So just install this and make a note where you are installing that file. Okay, just I'm gonna open the PyRx. No. Before PyRx, we have to do like protein optimization using Chimera, because I'm too familiar with Chimera. You can use any other editing softwares. I'll just go with Chimera. I'll open my Logan, like this will open. So by go throughing this website, like in the RCSB, we can know that this ID8, this is the mefenamic acid. So I'm gonna take this and then I'm gonna delete the rest of the things for docking purpose only. But those are essentially, in sometimes just go through the literature before doing this. So I'm going to select chain, like in the residue you can see ID8. So this is the, you can see here, right? Let me press N. So you can see the yarn right here. This is our active site. So we will use this as a reference, and we can use this as an active site. So for the protein preparation step, I'll just go and delete the rest of the things. BOG. So this is our protein, and then what will I do means I have to find the active site. So I'll go to tools and then surface binding analysis, like surface binding analysis. You can see Autodoc Vina, just click that and then it will show you this. So what you're gonna do is we're gonna create a grid box over this ligand, and then we will know the active site of it. So once you move the cursor to here, it will show in the bottom mefenamic acid. So let's create the grid box. So this volume, I'm gonna use this control button. So just make a random numbers. My professor advised me to go for the size of at least the size of the grid box till 20 Armstrong. So I'm gonna use this. So you will get a box over here. So what you will do means press the control and then click over there and then move the box to the place, to the active site. So place the grid box in a way that it covers everything. Oh my god, where's the box goes? Something happened. Okay, I'm gonna create the box again. So you can see the box over there. Just control and then click, move the box where you want. So it covers the whole active site of the ligand, I hope. Yeah, it covers the whole part. You and then this is it. So yeah, it is fully covered. So this is our active site. What you have to do means you have to make a note of this number. Like you can round off it. Like I'm gonna make this into 37.5, and then I'm gonna make up to 22.8, and then this one will be 61 itself. So this is the active site for this receptor. So once you make a note of this, just make a note of this using a pen or paper. Like you can take screenshot though. So this is the active site for this particular receptor. So once you make a note of this, just close this and then select, remove all the residues, actions, delete, and then again select residue, and there is I think there is a marker over there, and we can also delete this too. Delete this. So it is the protein alone. Okay, this is the protein alone. What we have to do is we have to prepare the protein for docking. Let's go to the tools. Okay, tools, surface binding analysis, dock prep, and then you have to add hydrogen and add charges. Click OK. OK again, and then OK. Here in the bottom you can see dock prep is finished. Okay, sorry. In the bottom you can see dock prep is finished. So we have to save this file, save pdb, save it as pdb file, Loga, and then that's the desktop, multiple docking. So here I will save it as cox2 prep. In this folder I will save it. I'm gonna save this in this folder. So I just saved the file, prepare file, in that folder. So simply we can close this, and we have to open the PyRx. Okay. So once you open the PyRx, you will have this interface where you have to click the start here. You can see in the Bina wizard, you can just click the start. So here we have the ligands and then macromolecules. First we have to do what we have to do is we have to manually, like, we have to import macromolecules. So we have to click add macromolecule here. The add macromolecule, we have to select that file, and it is in the multiple docking. Here you can see this is the prepared. You have to save the prepared file. Okay, open this and then click OK. So the macromolecule has been imported. So next we have to import the ligands. So what you have to do is first import the ligand, like that is any one of the ligand, and then rest we can import it by just simply copy pasting it in this folder. Okay, just click add ligand. So just go to the PDBQT and then click artemisinin. I'm just gonna add artemisinin. So right now artemisinin is introduced in the ligands folder. What we have to do means we have to simply clicking we have to import ligands one by one. It is a tedious process. What I will do means just go here in edit, in preference. You can see this is the workspace. You can also change the workspace also. So I'm just gonna use the same. So this is the workspace. What I'm gonna do is I'll just go to the files where I have keep the PDBQT. So except the one molecule I have already introduced, I'm gonna copy rest of the molecules. Just I'm going to that folder. Just go where I have saved it, and users, okay, logo, and then you can edit the MG tools. In the PyRx, you can see the ligands. Just paste the PDBQT files over here. So once you pasted the PDBQT files over here, let me show you again what I did. This PyRx. So this is the working space of the PyRx, and this is the folder where I have all the PDBQT. In the working space, you can find the ligands section. You can see artemisinin and everything over here. Like I just imported the artemisinin right now. So except artemisinin, you have to select every compounds, rest of the compounds, and then paste it here. And then what you have to do is just simply close this, and then in the PyRx, just close the PyRx and open it again, so that it will update all the molecules you have incorporated. Once the PyRx is started, just click start, and you can see every molecule has been incorporated. Otherwise, what you have to do means you have to import every ligand by one. So clicking add ligand, because this type of PyRx don't have multiple selection. So you install like everything. So that's it. Before in the next step, we have to make a grid bars. Let me show you how to make a grid bars. You can manually do a grid bars though. Like you can in the next step. So these are the ligands. How to select the ligands, everything. For the next step. So once you selected every ligand, just go for forward, and then in this step you have to manually drag the grid bars. So which I'm hurting it to do. So you have to do it manually. Action. So what we have to do is we have to simply readjust the grid bars to our interest. Since we have already identified our active site, I'm gonna reshape it to it like. So make the box size approximately 20 on each side, like I'm doing. It is kind of tedious process, but once you done, it will be good. From every axis, it has to be 20. Like it's your interest. You can, if you want to do blind docking, you can increase it until it covers the whole protein. So this is approximately 20. You can see here dimension 20 Armstrong on every side. What I am gonna do is I'm just gonna move it to my active side. So first one is 37.5. It will be helpful if you click x-axis and then you move it on one direction, so it will get the Y is now moving. So we want to place it in 2.8. So and then we have to move. If you move in up direction, you can see things. in eject axis it is 61 for me. Okay, 61, and then I have to place it in x-axis. So x-axis it will be 37. And then 2.8. Okay, this is approximately our active site. And then once we have made the grid bars, we have to click forward right here. So that's it. It will use the CPU or GPU to produce multiple poses, like docking poses of it. Let's wait until it get finished. So multiple docking has been finished.
Later.
So these are the results of the pole of the molecules with the of the ligands with the macromolecule. So here you can see this thing. So from this you can export this data. So by clicking this, it will save in CSV format. Just I'm gonna save it here. Results. I saved it. So let's open the file. Results of C. Let's open it. So these are the results. You can see artemisinin. For artemisinin, these are the poses, and then these are the binding energy, RMSD, and then lower. So you can see these are the results. So we can also get our results. This is the working directory, as I already showed you. The macromolecule section, you can see these are the output of the docking poses in the PDBQT format. In the analysis video, I will show you how to visualize the interaction between the poses and the receptor for every molecule. So stay tuned.